A warm good morning to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department, SNS College of Technology. In this video, I like to share a case study on pre-failure of boiler uh, reheater tubes in a power plant. Here we all know in our subject we have learned four types of failures. One is ductile failure, brittle failure, fatigue failure, and pre-failure. Here, pre-failure occurs as was already occurs mainly because due to the name boiler or reheater comes into the picture. Okay. Before that, we have to see what is the introduction about the or when the boiler is commissioned. The boiler was commissioned 24 years ago and it is operating more than 150 or 1 lakh 50,000 hours. So this tube material is made up of medium carbon SA192 steel. The nature of steel is seamless. The outer diameter will be 57.14 and normal thickness of 3.4 millimeter, and the work pressure is 345 psi. So here before cleaning we can see the pieces which is taken from this reheaters and after cleaning you can see the it is cut into pieces and it is cleaned. The first one is that in the microstructure of this boiler tubes were studied using microstructures, and we have seen in this microstructure we can see the structure of cross sections which contains ferritic perlite structure with the dispersion of carbides and accumulations at gain boundaries. In this, visually, when these carbides occurs in the gain boundaries, it will reduce the strength. If it is present inside the grains, it will increase the strength. But once it seen in the grain boundaries, the carbides or any precipitates will decrease the strength of the particular material. When we see the cross section of the third pipe, this is on the fire side, we can see this carbide is dispersed in the ferrite matrix and it is precipitated at the grain boundaries. As I already told, once the carbides are precipitated or formed in the grain boundaries, it will reduce the strength. While taking the cross section of the pipe 4, we can see a huge perlitic structure, and there also you can see a huge dispersion of carbides and accumulations at the grain boundaries. As I already said, in both this microstructure, we can see the carbides are dissipated or are seen here and there, or some in an accurate part we can say it is mainly present on the grain boundaries. Once this carbides present in the grain boundaries, it will reduce the strength or it will reduce the mechanical property of the particular material. So here the discussion comes like this. Here the microstructure studies reveals the structure is ferritic and perlitic. As in the class I already said, perlite is nothing but the combination of arsenic and ferrite, and second one is dispersion of carbides in the ferrite matrix. As I already say, in the ferrite matrix, carbides at the grain boundaries will reduce strength. Here it is seen the dispersion of carbide in the ferrite matrix compared to pelletic structure. Ferritic structure has low strength because of its single component structure. But even though added to that, you can see the accumulation of carbides at the grain boundaries will reduce the strength in this type of high temperature failures. The fourth one is that you can see the presence of voids in some cases. In some cases, we can see the presence of voids. Voids are nothing but small dips or small vacancies that is present at the atom range, or in some in macrostructure we can say some cracks like thing, right? So this observations provides a strong evidence that it's a creep induced failure. we can say with the two things. One is that the creep majorly occurs at a high temperature when the when it is undergoes thermal stress. So as I say, it's thermal and stress. So thermal heat and when it is made to go under stress, which is combined with the high temperature, creep will definitely occur. So likewise, other than boiler, the creep failures occurs at rocket engines or height the or the machines which deals high temperature like boilers, propellers, and gas engines, right? Here, added to the creep failure, this creep failures actually appears at the dominant during the current operation of the boiler. So it is no wonder that the creep occurs at the high temperature. Moreover, it also make cracks at the possible areas, and the crack propagates when the thermal stress goes on increasing. And here, so the next thing is that there is no crack or leakage which is found at the tube, which is indicates that the stage the crack has not reached. The thing is that here in some of areas no crack or leakage is found, but it which indicates that stage creep has not reached. There are three stages in creeps. First is creep, which is a primary creep, which moves on slower. The second creep is that the secondary creep where the creep increases based on the time, but if that can be that can be stopped here. That can be stopped. But once the stage 3 creep is reached, the material will be surely failed. So here it indicates that stage 3 creep has not been reached. So it is clearly indicating that the material may fail. The material will fail once the tertiary creep reached, or it may take some more time. The second evidence is the second thing is that the scale density or the scale thickness value of the boilers are high. But the scale density is that whenever the water goes on heater, we can see the white scales will be formed at the walls of the boiler. But even though they are operated without cleaning, but it has no major effect as like creep that leads to the failure. The next thing is that the next thing you have to speak about the conclusion is that the result of the metallographic studies it involves that the creep is the major part creep failure is the major part that happens. As I already said, the creep only occurs at a high temperature. Here the boiler pipes unit 3 and 4 is heated at the high temperature and at also high pressure, so the thermostats comes into the picture. So in this we can finalize that the creep is the only format, or creep is the only failure format that occurs. Here the recommendation comes is that for the reheated tubes from the boilers unit 3 and 4 can be under deterioration due to the influence of creep behavior. So we have to change the particular reheated tubes because it undergoes creep pressure, and they should be periodically monitored to avoid the creep failures at the future. And the better the tube material is like a low alloy steel is the better choice for the operating temperature about 500 degrees Celsius. So we can use low alloy steels. Moreover, my recommendation is that somehow or other the cladding can be done in order to avoid the what is a rust or and also we can use the alloy steels with super alloy steels which can undergo temperature about 1000 degrees Celsius, right? So as I already said, this is a case study on creep failure that occurs at the reheated tubes in the boiler, and in this the failure which just happens due to the creep is indicating that the creep failures can be solved once the temperature can be, the operating temperature should be lower, and also we have to periodically monitor the thermostats that acting on the particular tube or particular material or particular device. So we should avoid, if the crack or the creep starts in the tube, we should avoid reaching to creep 3, so that we can avoid the major destructions. So up to creep 2 we can get resolved, and we can uh, remove the particular material at a safer side, and also you can use it again, like use it with the new tubes. But when it reaches creep third stage, it surely get failed at any point. So for a steel which is operating at high temperature, it should be continuously monitored to avoid the creep failure. Thank you.